ATSAS program suite. Open the Primus QT program and go to the Open menu option. Here, select up to 13 data files of interest. The data files must be in the ASCII format, in which the first column is the S-vector axis and the second column is the intensity. Repeat this step for the buffer-only data, inserting this data into a second Tools menu. Next, navigate to the Data Processing window and select Subtract. This will generate a subtracted scattering curve representing just the scattering from the macromolecule of interest. To perform Guinier analysis, start with a buffer-subtracted scatter curve loaded into Primus QT. Next, click on Radius of Gyration, which will open the Primus Guinier wizard. At this point, a plot showing the natural log of the intensity versus scattering angle squared will be displayed. To obtain a preliminary radius of gyration, find the Command Prompt window and use the AutoRG function. After pushing AutoRG, click the upper limit up 1, then down 1 to force the program to update the statistical measurements. Alternatively, input multiple files at once by clicking the same Open prompt and selecting multiple data files' names by highlighting them in the same manner as previously described. To begin Kratky analysis, click to select the data file name. This will plot the data in the window, and then select Plot. Next, below the Plot button, click on Kratky Plot. As the result, globular proteins display a Gaussian peak, while unfolded proteins will display a plateau instead of a peak and resemble a hyperbolic plot like the one shown here. Load buffer-subtracted data for each concentration in Primus QT once again, and under the Processing tab, click Scale and inspect each curve and the I-scale number, which correlates to the dilutions made from the original sample. Following inspection, merge the data by clicking on the Merge button in the Processing window. To generate the distance distribution plot, load the merged data curves into Primus QT and then click Distance Distribution in the Analysis tab. Adjust the data range of the merged data to avoid any significant noise at the tail end of the raw data. Also, omit data points close to the beam stop in the low Q region by selecting the lower range value and increasing the number. To determine the Dmax, start with a range of 5 times the radius of gyration obtained from the Guinier analysis. Then gradually decrease this value until the distance distribution plot does not abruptly drop to 0 on the y-axis and does not have a long tail before approaching 0. Check that the experimental radius of gyration versus intensity plot, which is derived from the Guinier approximation, and the distance distribution radius of gyration versus intensity numbers are similar.